All right, so 2002 question 2, calculator problem. You got an amusement park problem where people are coming in, entering by the function E, and people leave at the function L. Both E, T, and LT are measured in people per hour. Now, if I'm doing the AP, first thing I do is I put people per hour up here on both of these functions, so I realize exactly what the units are. I don't want to lose track of that. And I also know if I integrate that with respect to time, we're going to get people, right? So we know what's going on there. These functions are valid 9 to 23. Oh, so 9 o'clock to 11 p.m. Oh, that's what it says. And at time t, there are no people. All right. So at time of 9, people equals 0. And that's going to be an initial condition for us later, I bet, for our fundamental theorem of calculus. A, how many people have entered the park by 5 p.m.? Round to the nearest whole number. So park opens at 9. You go to 17. How many people enter? Now how many people are there? So you just got to do E of t. So you just take that function, and that's something you're going to have to do in your calculator. I mean, it's impossible to do this by hand. And if I do that, this spits out 6,004.270 something. But it said, now this is one of those times where it said to the nearest person, you do not go 4 decimal places, so 6,004 people. And this one's pretty easy. But again, you think to yourself, that wasn't hard. But this is a point, this is a point, and this was a point. I mean, it's 3 easy points, and again, out of 9. So that was letter A. Letter B, the price of admission is $15 until 5 p.m. After 5, the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? Round your answer to the nearest whole number. Well, again, you got to see that the units on the cost of admission is $15 per person, right? So you're going to have to multiply by people to get dollars. So you're going to want to, I think units are really important in all these problems. So I would actually write $15 per person. I would integrate it. I would write the integral we just did, right? Up top, 9 to 17, et dt, even though I know it's 6,004. All right. Plus the integral from 17 to 23, et dt. And we don't use the function LT because people who leave don't get their money back. If it rains, you still pay at the amusement park. Oh, and I forgot the dollar amount. And those people are paying $11 per person. And you might say, well, it's person. Well, I might put people because the units I'm using is people per hour. And that's the units they gave, right? So, again, I would not overthink this at all. I would just do the math. I would do $15 per person times the 6,004 plus $11 per person times, and when I do this integral and then calculate, it comes out 1271.3, so 1271. And if we do the math here, okay, you get 100,000. 104,041. Again, not too hard a problem. All right, pretty straightforward. Now, it said to the nearest dollar. If you entered this in your calculator, these AP problems are designed a certain way. If you entered this in your AP into your calculator and kind of use fractions of a person, it's still rounded down. All right. They took the answer that came out of this. When you round it down, this answer is this. They gave credit for that answer too. Okay, one or the other. All right. The only thing, believe it or not, they only gave credit for what I boxed in. The number this time they didn't even give credit for. So it's just a 1-point problem, just for the blue box.
Wait, did it say that you get the integral and it be integrated, or?
Nope. You would have done it because it asked you to, but this is what the AP. You never know what they're going to get scores for. They only gave scores for the blue box. You didn't even have to finish it correctly. All right. Again, you don't know. I would not have guessed that. If you would have made me guess, guys, I would have guessed that it would have been a point for the integral and a point for the answer. Okay? That's what I would have guessed. All right. Letter C. Let h of t equal 0 to t, e of x minus L of x dx. And they just changed it from t to x. 0 to t, so that the variable here would not match the t in the problem. Okay? For 9 to 23 for t. The value of h17 to the nearest whole number is 3725. Find the value of h prime 17. And explain the meaning of h17 and h prime 17 in the context of the park. Okay, hopefully you catch this as entering minus leaving, right? So you take all the people that enter minus all the people that leave. That's how many people are in the park, all right? And this integral would give you how many people are in the park at time t, right now. So h of 17 is how many people are in the park. So 3,725 people are in the park. All right. They want you to find the value of h prime. So first thing I would do is I would start with h17 equals 3725 means there are 3,725 people in the park at 5 p.m. 17 relates to 5 p.m. Oh, that's that. Now, they want you to find an h prime 17. This is just fundamental theorem of calculus. If h of t equals the integral from 0 to t, right? We just plug in the t, and I could say this is all times 1, right? Because the derivative of t is 1. I would not bother doing that on the AP. So h prime is entering minus leaving. It's going to be the rate of change at the instant at 5 p.m. So I just have to go back and do e of 17 minus L of 17. And again, it gets a little small if I do an entire page, but I'm using the original functions, not changing them, right? Just plugging 17 in. If I do that and I grind it out, I get a number of negative 380.218. And that'll be people per hour, right? That'll be people per hour. I always want units here. All right. So that's the value, h prime of 17. So I answered that. Now explain the meaning. At 5 p.m., the number of people in the park, right, is decreasing at a rate of, I might do approximately, because you're going to round to negative 380 people per hour. Period. All right, let's see how I did. Okay. You get h prime of 17. Just the value, not the units, 1 point. The meaning here is a point. The meaning here is a point, and it must include a reference to time 17 or 5 p.m. It must include a reference to time 17 or 5 p.m. If you skip it, at time 12, it's not going to be negative 380, right? It'll be some other number. You've got to tie them together when you do these reasonings. All right, so 313, that leaves 2 points for the last one. box this all up. Let's push it off to the side and hide it. Last one. At what time t from 9 to 23 does the model predict the number of people as a maximum? Okay, we've already figured out the derivative, right? And we know that a maximum is going to happen at h prime. So we know h prime of t, right, equals e of t minus L of t. So I want to set h prime of t equal to 0. And this is a disaster in your calculator. You got to be careful because you need to enter the entire quantity minus the entire quantity equals 0 in your solver on the TI-84. Or or you have to. You just got to be extremely careful when you set this up. It's just a difficult thing. You got to make sure you use parentheses around the division signs. You just got to take your time. When I did that on my calculator, all right, when I did that on my calculator, I got time equals 15.794, and I have some decimal point. I gave credit for both of these answers, so it must have been 7947 or 7948 or something like that, the fourth decimal place. We go 4 places, so the third one gives us credit, all right? And at what time does the model predict the park will be max? Right there. And here's the thing. They want to see that this was equal to 0. I did it in 2 steps, right? You could have done it in 1. You could have just said this was equal to 0 here, all right? But you had to show that the derivative was 0. And then they wanted the time, 15.794 or 15.795. Not horrible, but definitely a calculator one where you got to practice to be efficient. So keep practicing.